So I considered whether or not to include this in the series, and ultimately I decided it was important, which is that we've talked a lot about one type of lighting. We've talked about strong directional lighting, which has sharp shadows. Well, if you have different types of lighting, you're going to have different types of cast shadows. Now, this is something that I'm going to go into a lot more detail on in Basic Rendering 3, which is coming soon. But for now, I just want to show the same scene, which is this cube in a simple room, rendered with a few different types of lighting. So the first one we're going to do here is sunlight. Now, in this case, the sun is coming through a window, and so it is not infinitely big. It's almost like I'm casting a shadow, and I use the exact same technique for that. But what I get is the shape of the illuminated sun. And this is going to be the brightest by far light in the scene. And for this imaginary thought experiment, we're going to have no artificial lights in the scene. So what you're imagining here is the light comes in at this very strong angle, and it hits the floor, and then it bounces. And if you remember from geometry class, the way things bounce is as if they were reflected across a mirror. So if we look at it inside view, the light would come in at this angle, and it would then bounce up, and it would illuminate another surface. So the way I would represent that in my rendering is to have sort of a illuminated back wall. And the back wall is going to be brighter than the side wall for this reason. There's also going to be a lot of other random bounces of the light filling up the space, which is going to give me sort of generally soft shadows. And it's really going to fill in that cast shadow that would normally be cast by the cube. But in a very, very simplified way, you can think of sunlight as being a strong beam and then a lot of bounce light. So there's really not going to be dark shadows anywhere. In fact, if you're looking around your house right now, if it's daytime, you'll see this. Open the blinds, let the sun come in. You still have a bright room, even though there's no lights on, but the brightest spot is where that sun contacts with the floor directly. So this next example is as if we had a candle in the room. And the first thing you probably notice is that you have very long cast shadows. Now, the way this works is similar to the way we were casting parallel light rays from the terminator's edge onto the ground plane. Except here, instead of parallel light rays, it's like a starburst. All of the light rays are coming out from a single point, emanating out towards the walls. And so all we need to do is connect those lines to the corners of our forms, and we get these exaggerated long shadows. But really the process is exactly the same. Find the terminator, connect it from the light source through the terminator to the ground plane. It was just a little easier before when all the rays were parallel. In this case, you actually have to pull lines back to the location of the candle. But really it's pretty straightforward. And so when we do this in our rendering, what we are left with is a cast shadow that's really much larger than the object itself. If you've ever been around a campfire, you've witnessed this in person. Now, light has a fall off if it is an artificial light. It is not as relevant for the sun. What that means is close to the light source, it's going to be bright, and then the further away you get from the light source, it's going to get dimmer and dimmer. So even if you have the exact same angle from the light to the surface, a close object will appear brighter than a far object. So this candle is going to be illuminating in all directions, so it's going to have sort of soft pools of light below it and on the walls, but then definitely a very brightly illuminated front face of that rectangle. As we get further and further away from the light source, it's going to be dimmer and dimmer. And then we're going to have a very pronounced cast shadow, and that's what we projected those lines from in the first place. But as well as getting dimmer and dimmer as you get farther and farther away from the light source, you also get softer and softer shadows. So the way I'll represent that here is by sort of softening up my selection here. And then as I fill it in, you can see that it starts very sharp at the base of the rectangle, and then it gets softer and softer as it's further away from the light source. So I like to think of these as sort of like a burst of energy. They are the very brightest right at the center, and they point out in all directions equally, hit stuff sometimes or don't hit stuff, and then as they get further and further away, it gets dimmer and dimmer. The only trick is that you make sure you are casting your shadows correctly because they are not parallel light rays, so make sure you trace the correct lines. The next type of light I want to talk about is an area light. That's what they call it in 3D software. You might think of it as a big fluorescent light panel, a light box for photography, or really even a window on a cloudy day. It's sort of equally glowing from all different points. And the way we are going to think about that in simple terms is it casts a soft shadow. But the question is, where is the shadow? How do we project it like we've been doing before? Well, the way I like to think about it is think of a single point light, just like the candle. And if you were to project shadows out from it, this is what you'd get. Well, then think about another point light next to it. So here we cast the same shadows in the same way, and we have a sort of different lighting arrangement. Well, let's add those together. When you add them together, you can see there is a bit of an overlap. They both had large cast shadows, but over near the edges, they are sort of filling each other back in. But directly behind our shape, there is still a dark cast shadow. Well, this is the general principle. Instead of a point light like a candle, or parallel rays like the sun, what we have is like a grid of point lights. So here, this rectangular glowing box you can think of as rows and columns of point lights. And like before, if you were to envision what happens when a bunch of these independent point lights overlap, you only have a little area right in the center that remains dark. Well, that's the result. They all overlap, there's a lot of illumination, but where none of them are able to reach, that's where you have shadow. So this just takes a little bit of imagining, but eventually you'll start to be able to see what a large glowing area light would look like. These are very common in interior spaces. If you go to the library or your school, area lights are very common. They make things look nice and friendly, and they have very soft, gentle shadows below them. So the real takeaway here is that the rules I've been explaining for most of this series pertain to a specific sort of light. Now, directional light, in my opinion, is the best way to showcase form. If what you want to do is describe a cool concept art piece, directional light's just a good choice. But as I've shown here, other types of light yield different types of shadows. The form shadow, the cast shadow, they're just going to be different if you have sunlight or a candle or an area light. So if you want to learn more about this, make sure to keep an eye out for Basic Rendering 3, where we'll talk about this and surface materials. But just keep this in mind when you're working from your imagination, that the rules are not always the same.